So I'm John Kodumal. I'm a developer on the integration team in San Francisco, and I'm going to be talking about big modular plugins. And my goal here is basically to get you guys to a point where you can build a large plugin with some aspects of modularity to it. Now, modularity itself is a pretty big topic. There's a ton of aspects of modular design. In fact, there's a quote that from this famous Chief Justice who said, in a completely different context, well, I don't know what it is, I don't know how to define it, but I know it when I see it. And I kind of think that that's how modularity works. If you ask me for a one-sentence definition of modularity, I'd be hard-pressed to provide that to you. But what I can talk about are characteristics of modularity. So if I look at a piece of code or a plugin or something like that, there are aspects of it that I can point at and say, hey, it looks like you have a modular design there. For example, there might be technologies like dependency injection, where your components are loosely coupled, and that allows you to do testing more easily. Things like service-oriented architecture, where you're breaking your system up into sets of services, decompositions into APIs and SPIs, and so forth. And I can't really focus on all of those. I can't really teach you guys how to do that kind of development in this talk. It's kind of like a lifetime goal as a developer is to learn how to build for modularity. But what I can talk about is a specific set of aspects that are more common to the Atlassian ecosystem. So in the Atlassian ecosystem, we have a set of technologies that you use when you're building plugins. Things like the Atlassian plugin system itself, the OSGI layer that the Atlassian plugin system uses, and Spring Dynamic modules. And so what I can do is tell you how to use those in a maximal way so that you can build a plugin that leverages those things as opposed to just sort of tolerating their presence, which is, I think, the state that most of you guys as plugin developers are in at the moment. So the way I think of it, the running theme that I'm going to have throughout this talk is that your plugin is kind of existing in this pretty complicated environment. It's got things like the plugin system, OSGI, Spring DM, like I said, and all of those things and all of those components are basically going to affect how your plugin operates or whether it operates or not. And what you want is for your plugin to be resilient to changes in that environment. So over time, with minor releases of Jira, Confluence, any of our applications, that environment is going to change, and your plugin may not change. You don't want to redeploy it maybe for every minor release. So if you follow the best practices that I'm going to outline here, you'll get to a point where your plugin is more likely to work across those minor upgrades. It's going to be more resilient to change. That's the aspect of modularity that I want to talk about. And I'm going to do all this within a specific context, and that context is the Universal Plugin Manager. The Universal Plugin Manager is a big cross-product plugin that we built in San Francisco. And it's open source, so you guys can follow along. There's a link down here. You guys all have laptops, and if you're not looking at Facebook or looking up Batman on Wikipedia, you can follow along. That's a fisheye link. You can check out the source. If you're doing that, then the parts of the source that I'm going to be focusing on specifically are going to be the palms, like the plugin palm and the root palm, because a lot of the stuff that I'm going to be talking about ends up being configured in Maven. Let's see. Yeah, so a little bit more context about the UPM and why it has this modular design. We were given the task of building the UPM in about March or so, that kind of time frame. And we were asked to deliver a shipping UPM by Summit, basically, which happened in early June. So that's 3 or 4 months. So we had to go from 0 to a 1.0 release in about 3.5 months or so. And that's a pretty tight timetable, and it led to a bunch of constraints. And those constraints impacted our design. So the interesting thing about these constraints is that they're constraints that you guys as plugin developers face all the time. So the UPM itself and the source code is kind of a good template for you guys because it's basically, the way we built it operates under the same constraints that you guys face every day as plugin developers. Let me enumerate a couple of those, and you'll see what I mean. The first constraint that we had is that because we had such a short time frame, we wanted to deliver the UPM to you guys in 4 months. We actually couldn't integrate it into all the products directly. We didn't have time to actually get it into the shipping products. So what we did is we set a goal of having a downloadable version of the UPM available by Summit. Now, one of the aspects of that is that it's pretty difficult to actually install multiple dependent plugins in an Atlassian application. We don't really provide many facilities for that. So one of the constraints that we had is in order to make it a downloadable, easy to install artifact, we had to make it a single plugin. And that's kind of at odds with modularity. It's kind of what you guys are doing now. I mean, how many of you guys distribute plugins that are composed of actually multiple plugins that depend on each other dynamically? Yeah, so very few of you. But that's actually a good practice. I mean, that's actually something that you want to do. Despite the fact that we don't make it easy for you, for modularity, it's best to decompose a plugin into multiple products. So in the OSGI world, if we were just dealing with vanilla OSGI, a better practice would be to take a plugin and distribute it as multiple small bundles. But we couldn't do that. We had to deliver a single plugin. Despite that, we were able to build a modular architecture. Another constraint that we had is we wanted to make the UPM cross-product. So it had to work across all the Atlassian applications. And that has two interesting aspects to it. The first is that we could only depend on the cross-product APIs that Tim talked about. We were unable to use any product-specific stuff. Anything product-specific was a complete non-starter. The other aspect to cross-product design that's interesting is that, like I said, if you want to build a cross-product plugin, it has to work across all of those products, and all of those products have slightly different variants of that living ecosystem, the plugin system, Spring DM. So each Atlassian application basically is going to have slight differences in the versions of Felix that are sitting around at runtime, the bundles that we make available to you. And so we had to make the UPM resilient to that. We had to make it work in all of these products, despite the fact that there are subtle differences between them. Now that's relevant to you guys, even if you're not building a cross-product plugin, because if you follow these practices, even if you don't need your plugin to work across all the products, you want it to work across small, subtle changes in those products. That's something that you guys face every day, so that's relevant to you. Another constraint that we had is that we had to make the UPM work without any product changes. So we had a 4-month cycle. We basically couldn't get any changes into the products in time. That's obviously something you guys face. You don't really have an opportunity to say, hey, look, there's a bug in Jira. Can you fix it? My plugin won't work with that. Well, you can do that, but it'll take several months for you guys to see that change. The last constraint that I think was kind of interesting is that we had this requirement that someday, in some form, we might want to bundle the Universal Plugin Manager in Studio. And Studio is kind of a different beast than the standard Atlassian applications. It behaves in different ways. And how that impacted us is we didn't exactly know how we wanted to integrate UPM into there, but we wanted it to work with few code changes. So we kind of had this open-ended requirement that some of the behaviors had to be pluggable. So a great example of that is the permission system in the UPM. So in the UPM, everything you do is guarded by a permission check. And what we wanted was, well, we knew that in the behind the firewall instances, those permissions were going to be rather different from the permissions that we wanted in the hosted product. So we had to make that pluggable. So we had to allow you to override those permissions. But we still had this single plugin requirement. So these two things are kind of at odds. We want to distribute one artifact, but we want you to be able to override the behavior in specific ways. So I'll talk about how we did that as well. Okay, so I love the 38th governor of California, and I think we should just finish up with the context and get started. So let's just do it. Let's just go into the details. There are going to be two aspects that I'm going to talk about in this talk. Those are dependencies and services. And the distinction is pretty obvious, but I just want to outline it right here. Basically, a dependency is, well, if you want to use a library in your plugin, that's a dependency. And so I'm going to be talking about how you can actually declare and use those dependencies and what those will look like at runtime, because they're actually quite different. Services are a little bit different. Services are about communicating with plugins, with other plugins on the host application. So whereas dependencies are about sharing types or libraries, services are about sharing object instances and communicating data between plugins. So I'll talk about dependencies, how to use libraries, and I'll talk about services, how to consume services and communicate with other plugins. And we're going to start with dependencies. So if you're developing a plugin, you're in the Java ecosystem, you're almost certainly going to be wanting to use an open source library out there. So the first question is, how do I actually use that in my plugin? It may seem like something obvious because it's something that you guys do all the time, but it turns out that there are some subtle details that you should know about. I kind of think of this as in terms of a flow chart. So if you want to use a library in your plugin, the first thing you want to do is determine whether the product already provides that library for you. So how many of you guys were aware that the running products provide certain libraries like Google Collections for you automatically to use? Anybody? Yeah, a few of you, but not everyone. So that's kind of an interesting thing. I think what most people are doing as plugin developers is just going, okay, I'm just going to include, I need this library, I'm just going to include it in my plugin. I would recommend that you not do that, and I'll talk about why in a little bit. So but back to this flowchart, if you're deciding to use a library in your plugin, the first question you need to ask is, does the product provide that library? And that kind of leads to a small sidebar. How do you actually know what's provided? Unfortunately, we don't really have much documentation into this. We don't really tell you what's provided. And furthermore, we don't really advertise things in a very obvious way. Hopefully that's something that will get folded into the platform over time, but it's not part of the Atlassian platform at the moment. But what you can do is if you're using AMPS, if you start up your product instance with AMPS debug or AMPS run, AMPS will automatically include a little servlet called the Felix Web Console in your running application. You can navigate there through the URL here. It's a base URL of your running application, followed by plugin servlet system console. And this servlet, you don't need to read the screen in a very detailed way, but this servlet gives you a lot of details into the OSGI underpinnings. It'll tell you basically every bundle running in the OSGI system, what its state is, what services it exports, and most importantly, if you're looking at dependency management, it'll tell you what packages are provided by other bundles. So if you pull this up and you're looking for a library, you can check whether it's listed in there. Now, if it is listed, then you shouldn't actually include a copy of that library in your plugin. Instead, you should just use the one that we're providing for you. And there are a number of reasons you should do that. One is that it's going to reduce the size of your plugin jar. Another is that there are going to be fewer copies of the same library running around at runtime. So we're going to save permanent generation space. Another is that things will break. Things will be more likely to break if you use your own private copy. And I'll talk about why in a little bit. Okay, but let's say you're in this great state where we do provide that bundle for you. In the UPM, a great example of this is Google Collections. So we use Google Collections pretty extensively because we like transforming collections in a functional style. And Google Collections is a pretty good way of doing that. So it turns out that all of our products provide Google Collections. So how do we take advantage of that? Well, there's just two simple things that we have to do. The first is in your POM XML, where you declare the dependency as you normally would, instead of using scope compile, you use scope provided. Okay? What that does is instead of including a copy of that library in your plugin jar, it will allow you to just wire yourself to a bundle providing that at runtime. Basically, you'll get a class loader hook. Your bundle or plugin, I'm using the terms kind of interchangeably in this talk, your plugin will have an ability to load classes from another plugin or bundle that provides that package. There's one more thing that you should do, and that is there's a section in your plugin POM called import package. Actually, your plugin by default, if you create it with AMPS, won't have this section. It turns out that this stuff is automatically generated for you by default by AMPS, but I actually would prefer that you don't use that. So if you actually manually specify this import package section, that's a best practice, I think, too. What this is basically is it's a bunch of OSGI manifest headers. It tells the OSGI system how to interact with your plugin. Like I said, AMPS will generate this for you automatically, but it does so by scanning bytecode. And it doesn't always come up with the best list of package imports. So this is determining essentially what your plugin is going to connect to at runtime. So you kind of want to have pretty good control over that. I wouldn't kind of just leave it up to chance. Well, the plugin system isn't exactly chance. It's not just guessing. But you want to do it yourself. OK, so the way this works is you have an import package section. It's a list of Java packages. And each package also has a version. Any code in these packages that's exported by another bundle will be made available to your plugin. So in the UPM, to use Google Collections, we have this import for com.google.common. That's the base package for Google Collections. And we say version equals 1.0. Now, there's actually a little bit of detail on OSGI versions that I think it's useful to know. So if you saw there, I just said, hey, version 1.0. It turns out in OSGI land, versions have semantics. They're not just arbitrary strings. And those semantics come into play at runtime. So in OSGI land, a version has 4 parts: a major, minor, micro, and qualifier part. Major is the only thing that is required. So you can say version 3, and that's a valid OSGI version. Or you can say 3.0, or 3.0.1, or 3.0.1 snapshot. All of those are valid versions. The first 3 parts of that have to be numeric. Everything but the qualifier is numeric. The qualifier itself is just an arbitrary string. Now, the versions are ordered by OSGI. So any version can be less than, greater than, or equal to another version. And the semantics of the version ordering are pretty simple. They're sorted by major number, minor, and micro, and then finally by qualifier lexicographically. So version 3.0 is less than version 4.0, as you would expect. It's kind of sane in that respect. But there's even more detail. So in OSGI land, in those import package directives, you don't actually specify just a single version. You specify a range. And a range is basically 2 versions, a lower bound and an upper bound. So 1.0 to 2.0.3 is a valid OSGI version range. And the range can be specified using brackets or parens. A bracket means inclusive. So whatever bound that's on, it means inclusive of that bound. Paren means exclusive. So whatever bound that's on, it means exclusive of that. So this version that I have here is an example, 1.0.0 to 2.0.3. That's any version in that range. Doesn't include 2.0.3 because I used a paren. It does include 1.0.0. And finally, there's actually a gotcha that I kind of hate about OSGI. If you're in a context where OSGI expects a version range and you specify just a single version, it'll basically say, okay, that's the lower bound, and the upper bound is infinity. So if I say this, I want com.google.com and version 1.0, version equals 1.0, that actually means any version greater than or equal to 1.0, because it's expecting a version range there. So equals actually means greater than in OSGI, which sucks. And so you might ask, what's the best practice here? Well, it's actually not something that the UPM is doing correctly. So the UPM I kind of am putting forth as an exemplar of best behaviors in terms of this modular design. This is one case where we kind of didn't get it quite right. The best practice that I think you should follow when you're specifying these things is to set the floor, the lower bound, as the version that you're compiling against, and set the ceiling to be the next major version exclusive. So in this particular case, what the UPM should be saying, but is not saying right now, is, hey, I depend on Google Collections version 1.0 to 2.0 exclusive. Now, what impact will that actually have? Well, this will match any minor release of Google Collections from 1.0 to 2.0, but not including 2.0. So basically, we'll pick up any minor revision to Google Collections, but not the next major release. And the idea there is that in a minor release, where hopefully the library maintainer is not going to break the API, but in a major release, they might. So I'm hoping that Google Collections follows that practice, and if so, this would be the best version constraint to specify. Now, you can get even more paranoid. You can specify a more restricted range if you realize that that library is breaking API in minor releases. Like I said, this is not something that the UPM does quite yet, but hopefully it'll get there. Okay, so that's what you do if the product does provide the bundle. You go ahead and you use provided scope, and you import package, and you specify the right version. Now, what if you're kind of unlucky and the product doesn't provide the library at all? Well, then you kind of have to ask some more detailed questions about the usage of the library in your product before you include it as a dependency. And specifically, you need to know whether your plugin is going to be communicating with the outside world and interacting via that library. In other words, let's say you're importing a component, and that component declares a function that returns a Google collection or something like that. If that is the case, then that return type needs to be shared. They need to be in the same class loader. They need to be the same copy of that library. If they're not, you're going to run into all sorts of problems. But let's imagine that you're absolutely 100% sure that there are going to be no interactions, that type is not going to leak out into the outside world. In that case, you can just use the bundle class path. Basically, you can embed a copy of that library in your plugin. In the UPM, whoops, wrong way. In the UPM, we do that in one specific place. We use a library called JodaTime, which is basically what the Java date API should have been if they didn't mess it all up. And it turns out JodaTime is provided in some of our products, but not all of them, I think. So that's the reason why we use bundle class path in the UPM. We're also using it in the UPM in a very specific way. So there's one place in the UPM where we use JodaTime, and that's to send JSON representations of date objects back in the audit log. So basically, we're creating a datetime object and then just immediately turning it to JSON and sending it back. And that's really the only time we're using JodaTime. So we decided, OK, there's no way that this is going to leak into the outside world, and we're going to go ahead and use bundle class path. What does that look like? Well, you declare your dependency and you use compile scope. And by doing that, you're going to get a copy of that library in your plugin jar. So if this is me expanding the Universal Plugin Manager jar, and you'll see that that jar is actually included in the UPM. And that jar is going to be completely private to the UPM. So no one else in the world can see my copy of JodaTime. And if any of my types leak out, so if I ever return a datetime object to some other plugin, if the UPM communicated with other plugins, you would probably run into problems because those plugins wouldn't be able to see those types. OK. Well, what's a better practice? The using bundle class path alone is kind of the thing you do as a last resort. Unfortunately, I think it's probably what almost everyone is doing today in terms of dependency management for their plugins. A better practice, if the library that you want to use is not provided by the plugin, is to use bundle class path. Let me zoom out on that a little bit more. Is to use a bundle class path, but also do an additional thing called a self-wire. So what the hell is a self-wire? Well, we use it in one specific place in the UPM. Well, we use it in several places in the UPM. One of them is a library called Jackson. Jackson is a library that does JSON serialization, and we use it for all of our JSON representations. Now, we absolutely had to use this self-wire technique in the UPM, and the reason is because it turns out that there are multiple versions of the REST plugin, so the REST plugin that Tim talked about. Some of them expose Jackson, so some of them let you use their copy of Jackson, and we realized that, but some of them don't. So an earlier version of the REST plugin actually didn't expose Jackson to the outside world. And so we bundled it with ourselves, and then all of a sudden in the future version of Jackson, or in the future version of REST, Jackson was provided. So we kind of have this world where we have some environments where Jackson is provided and some environments where Jackson is not provided. So this self-wire technique lets you be resilient to that scenario. Basically, what you do is you declare your dependency as normal and you use compile scope. So just like before, that's going to include a copy of that dependency in your plugin jar. But you do two other things. You both import that package, so you import Jackson, and you export that package. So here we have org.codehouse.jackson. It's both in my import package and my export package directives. So what that's saying in the OSGI system is, OK, make this library available. I'm going to provide this library, make it available to the outside world, and let me use it too. And so what happens is that there's basically a self-wire. There's basically a hook into your own class loader. And OSGI will basically prefer to share those libraries as maximally as possible. So if somebody else is providing Jackson, the UPM will wire to that. But if we're in an environment where Jackson isn't provided, it'll wire to itself. So that's kind of the best of a lot of worlds. So whether or not the thing is provided, that's cool. We can use it, and we can maximize sharing. So that's my flow chart on dependency management. As a summary, basically, you should try to use a provided bundle if at all possible. If we're not providing the bundle for you, try to use a bundle class path and a self-wire. And if you're absolutely 100% certain that you're just going to be using a private copy of that library and it's cool, then you can just use the bundle class path and skip the self-wire technique. OK, so that's how you deal with dependencies. The next part of my talk is dealing with services. And basically with services, we're not just sharing libraries. We're actually sharing data. We're sharing runtime objects at runtime. Now, in OSGI, there's actually a pretty rich service layer. And it's actually a pretty complicated thing. It's not the simplest API to deal with. So luckily, the plugin system kind of abstracts away the services stuff for you. It does that by providing a library called Spring Dynamic Modules. And so what Spring Dynamic Modules does is basically it bridges you between Spring and the services stuff in OSGI land. So basically you can not worry about services, you can worry about Spring. So if you know Spring, you're in good shape. And so that's kind of the way you should interact with services. So if you're not doing anything crazy, then you can actually just skip the whole services stuff. You don't have to worry about OSGI services. In fact, you don't even have to worry about Spring because we'll do some transformations on your Atlassian plugin, plugin XML, and you can just use component import. So there's this thing, component import, that Tim showed. Are you guys familiar with this? How many of you have done component imports in your plugins? Okay, so what component import is doing is basically, it's basically a wrapper. It's transformed into Spring XML. It's exposing a Spring bean to you. So in this case, all you have to do is, in this case, I'm importing the user manager from SAL. So the shared application layer that Tim talked about, I'm using a bean called the user manager. Now that thing lets me determine who the currently authenticated user is, whoever's making the request, and that lets me do things like permission checking in the UPM. So if I'm not doing anything crazy, I'm just going to throw a component import in my Atlassian plugin XML, and then boom, I can just inject the thing. I don't have to worry about anything else. Now under the hood, it turns out that this Spring Bean is an OSGI service, and this user manager object that I'm constructor injecting is not actually a user manager, it's a user manager proxy, and that proxy has all of the sort of lifecycle part of the of OSGI services completely hidden from you. Okay, so if you're doing something mildly crazy, you're not just doing a standard component import, you can actually drop down to the Spring level. When would you do that? Well, you would do that if you're doing something where the component import syntax just isn't expressive enough. So examples of that. If you're injecting a collection of services, so imagine you have a translation service and you're injecting a Czech translation service and a Polish translation service, and you want all of those. Component import's not going to get you there. You need to actually drop down to the Spring level. Another example of that would be service rankings. So in OSGI land, you can actually, like if there are multiple copies of a service running around, they can be numbered and you can pick the highest number and do things like that. So if you want to get fancy, you can get fancy by talking to Spring DM directly. What does that look like? Well, in the UPM, we actually never needed to do this, so I kind of just invented this. You're not going to see this in the actual source code. But basically, you can just make a Spring config file. In this case, I've made a file called metainf.spring/springcontextosgi.xml. And I've just got some XML here that declares the user manager as before. This is going to do exactly the same thing as what component import did, because I'm not doing anything special like injecting a set of user managers or anything like that. And if you want to get more details on this, I would look at the Spring Dynamic Modules documentation. That'll give you everything that you need. Okay, now if you're doing something even crazier, you can actually go down to the bare metal. You can go down a level. Instead of talking to Spring, you can talk to OSGI directly. Now, I would not recommend that you do this because the OSGI services layer is more complicated than just dealing with Spring. Spring DM is hiding you from a lot of the lifecycle stuff that OSGI has. But if you need to talk to OSGI directly, you can. Now, there's one place where we did this in the UPM, and that is with our permission service. We were in kind of this strange position where we had to have a single downloadable plugin. So we needed a default implementation of the permission service within that plugin. But then we wanted other products to be able to come in and say, I want to provide this service that's going to override the service that's declared in your plugin. And the way we did that was by going to OSGI directly. If you're following along, this happens in the permission enforcer in the UPM. And you're going to see from the complicated nature of this example that there's a lot of stuff going on and that you probably shouldn't do this unless you have a really compelling reason to do it. Okay, so how does this work? Well, we ended up, there's actually a lot of ways that you can declare a service and consume a service in OSGI land. In here, you're not going to look at the Spring DM docs. If you want to do this, you're going to want to look at the OSGI APIs directly. The way we went about doing this is we implemented an interface called Bundle Context Aware. That gives you some setter injection. you get a method called setBundleContext that gives you a bundle context object. From that bundle context object, we actually created a service tracker, which is a utility which lets you track a service at runtime. So it's basically a listener that tells you when a service goes away or comes into life. Now, this is kind of where the OSGI services stuff gets hairy. So one thing that you cannot do with a service is cache it. So you can't just grab a service and store it in a field. And that's because the services can go away. The references aren't going to be valid over time. So that's what the service tracker does for you. Every time you want to use a service through a service tracker, you have to do a lookup. So you have to call a method on the service tracker. That's what I'm doing here in this lookup permission service method. I'm asking the service tracker for an implementation of the permission service. It may or may not be null. If it's null, then I can use the default. That's the one that the UPM is providing for itself. If it's not null, then it can go out to that other plugin and ask for that other permission service. Now, there's even more state management here, which is another reason I don't like this. These permission service trackers are actually resources. They're listeners, so you have to close them when your bundle goes away. And we did that by closing it in the destroy method. So there's a lot of stuff going on there. If you need to do that, then I would recommend that you look at examples online, things like the UPM or the OSGI documentation directly. But thankfully, there are very few instances where you should be needing to consume services directly. Ideally, like I said, you want to use component import. If you're doing something funkier than that, drop down to SpringDM. And then only then, if SpringDM can't do what you want, should you go down to OSGI directly. All right, so I think I'm finishing up a little bit early, which is good, because I think Matt Dorr is going to want to ask me some questions or yell at me, or maybe a combination of the two, and that'll be fun. But what I want to talk about now is the payoff of all this. So I just talked about things that you would normally take for granted as being simple in Java development, like using a library or calling other code, really. That's all what services are about. But what is the payoff of all this? Like I talked about all these complicated ways of doing these things, well, mildly complicated, but there has to be a payoff. And Dan alluded to this yesterday when he talked about the future being in a particular direction. So this stuff is not free. You have to do a little bit of work, but the payoff, I think, is well worth it. And I'll provide some examples right now. So let's imagine a world where the UPM is shipping in one of our products, and then in the next minor release of that product, we decide, hey, there's a new version of Google Collections out, and it's got some bug fixes. Well, it turns out that because the UPM is not just using a private copy of Google Collections, it's wiring to another bundle that provides Google Collections, it'll just automatically wire to that new version and get those bug fixes for free. So that's a really good thing. That's one of the major benefits of modularity. You can just get new bug fixes without any code changes for free. Now, let's take a look at the flip side of that. Imagine we decide to add Google Collections 4.awesome to the product. So there's a new version of Google Collections. It's so sweet. It's super functional. But it breaks the old APIs. Well, let's imagine a world where we fixed the UPM to specify those version ranges properly, and we were smart enough to include the old version of the Google Collections bundle in the running product. If we did both of those things, and a new version of Google Collections came along, a new major release, it turns out that the version constraints that we specified for Google Collections would cause us to wire to the old version. So we wouldn't wire to the API breaking version. And automatically, we would continue to work despite that upgrade. So with a little bit of work, we can get to that point. Now, let's talk about two scenarios that actually have already happened. So imagine a world where a library in some environments, so like let's say Jira 4.1 gives you a Jackson bundle, but Jira 4.2 doesn't. This actually happened with us in the REST module. Well, by self-wiring, we're kind of resilient to that. So in the first case, if the product doesn't provide Jackson, we'll just use our own copy and everything's kosher. But if the product does provide Jackson, we can just wire to that version. And then if scenario 1 comes along, and a minor release of Jackson comes along with bug fixes, we'll go ahead and pick up those changes for free. So we kind of get a lot of good benefits by doing the self-wire. And the last thing is the custom permission stuff, the pluggable behaviors that we got with the UPM. So the way this works now is kind of what I alluded to before. If a product wants to provide an overridden version of our permission service, it can go ahead and do that. with no code changes to the UPM itself. It just has to create a new plugin, implement one interface, and at runtime, the UPM will determine whether to use that or to use its default. So this gives us the ability to deploy the UPM in Studio in any of the running products with different permission systems and have them just be able to modify those permissions however they see fit without any changes to the core UPM. So that's another big payoff. And I think that's all I have. Hopefully I've convinced you guys that you should be following these practices, and hopefully you'll be building more modular plugins in the future.